Let's look at Euclidean geometry. The first question goes as follows. Classifying triangles. Triangles ABC has sides AB equals to 8 centimeter and AC equals to 8 centimeter as well. So those are equal. And BC equals to 10 centimeter. Therefore, we have two sides that are equal and one side that is slightly bigger than the two sides by about 2 centimeters. So let's try to illustrate this in the form of a triangle. Never mind my not so very straight lines. Okay, and then it says BC. To make this a BC, and then you have your AB and your AC being 8 centimeter each and 10 centimeter. Okay, then it says therefore classify the triangle. So we know from what we have learned, the theorem, that there's different types of triangles and they got names. Now this particular one, where we measure the sides and compare them, we see that AB is equal to AC, both. Since two sides are congruent, this is an isosceles. So let's remember that from what we've just learned. So what we're having here is an isosceles, because of the two sides that are equal. Okay, I hope to remember that. Then we move on to the second calculation. It says finding angles in a parallel line. Line MN is parallel to line ST. Okay, so let's have two parallel lines. Then it said the first one is M, N, then you have ST. Okay, and they continue to say if transversal line PQ intersects them at point AB. So there's a transversal line that intercepts them. And then they say those points are point A and point B. Okay. Then they continue to say respectfully. Then and angle PAN, which we determine that our transversal line is PQ. They say PAN angle here. Okay. Is the degrees for it is 45 degrees. Okay. And then they say find angle ABT. ABT. So you're looking for this particular angle. Okay. Now they continue to say since MN is parallel to ST. So this line is parallel to this line. And it is and the line is transversal, which is our line PQ in this instance. PQ is a transversal. We know corresponding angles are congruent. Therefore, corresponding angles, remember we learned that, corresponding angles. Therefore, angle PAN is congruent to angle ABT. Therefore, angle PAN is congruent again meaning similar to ABT. So hence, therefore, the conclusion is that angle PAN is equals to 45 degrees and also equals to angle ABT. So these two angles are equal, being 45 degrees. So that is corresponding angles that you find where there's two parallel lines with a transversal line crossing them at 2 points. Then we continue to the next Question number 3 saying using the Pythagorean theorem, right angle PQR, right angle, keywords, right angle, let's get all the right angle, Pythagorean theorem. Then it says PQR, right angle. Then it says PQR, and combine the two, because it's a theorem of Pythagoras. And then we are given PQ and QR, which are the legs of a triangle. We can use the Pythagorean theorem, which is PR squared in this instance. So PR squared going to be our side here. And then right here, going to make it squared. And then we're going to have also PQ squared. And then also going to have QR squared. Okay. And then when we simplify, because we are given these values, we are going to go as follows. Theorem of Pythagoras says the PR squared is equals to PQ in this instance is given as 3. So it's 3 squared plus, and then your PR is given as 4. So you say 4 squared. Therefore, you're going to have 9 plus 16 is equals to 25. Okay. But then now that you're looking for PR, you're going to say PR is equals to the square root of 25, which is equals to 5. So that's your final answer in terms of your PR that you were required to calculate. So that's how then you go about doing that using the theorem of Pythagoras. Now let's move on to the next question, which is area of a triangle. A rectangle has a length of 7 centimeters and a width of 4 centimeters. Calculate its area. Now, analyze each and every word given. Rectangle, length is given, width is given. So length, longest side, then you have your width being given as 4, and then you have your length being 7. And then they say calculate the area. Now we know that the area is always equals to length times width. Okay, I was going to say length times breadth. And that will be equals to, we have our length being 7 times 4, and that gives us 7 times 4, that is 28. That is, now in terms of units, always remember that you're going to remain with, now that you're working centimeters, going to be centimeter squared. That's to indicate that this is an area. So this particular area that is shaded here is 28 centimeters squared. Now let's move on to the next question, which takes to talk to parameter of a parallelogram. Now, again, always analyze the shapes being given because they are a guideline in terms of what needs to be done. So let's look at the question says parameter parallelogram. Parallelogram ABCD has sides AB equals to 12 centimeter, AC equals to 8 centimeter, CD equals to 12 centimeter, and DA equals to 8 centimeter. Find its parameter. Okay. Now let's go ahead and solve this particular one. Parallelogram, still remember the keyword is parallel. So you're definitely going to have parallel here. And then it also has other sides which are also parallel. Okay. It's always easy to remember parallelogram because almost every opposite side is parallel to each other. So this will parallel to this, and this will parallel to that, and this will parallel to that. Okay. which makes the opposite angles equal, like this angle here, and this angle here, this angle here, and this angle here will be equal. But let's continue with our calculation. They say find the parameter. So in the parameter, you have your A, B, C, D, the shapes been given. So you got your A, then you know that AB, the longer side is 12. And then you got C, which is BC, been given as 8. And then you have the parallel side that are equal. Again, you got a 12 here. And then lastly, got a DA, which is an 8. So therefore, you have your both sides opposite each other being 8, 12, and the opposite side also being 8, both of them. So how you finalize this is that, you know, parameter is the total measurement of all the boundaries sides combined together. So in this instance, you're going to say, therefore, a parameter will be equals to AB plus BC plus CD plus AD. All that is 12 plus 8 plus 12 plus 8. Okay. Now we know that 12 and 8 is already 20, and another 20, then it will give us 40. And remember, it's centimeter in this instance. Okay, because it's linear. It's not an angle, which is, it's not an area, which is centimeter squared. So this will be your units for this particular parameter that you would use as a boundary for this particular parallelogram. Now, moving to the next question, it talks to identifying congruent angles. Now, the triangle XYZ has an angle X and angle Y, which is equal to 70. Okay, so I've been given two angles in this particular triangle. So it's a triangle which has, let's draw it, a 70, and also it's got a 50. Okay, and then this one is not given, and then it's called X is 50. So let's put it here. And then Y is where 70 is. So this is Y. And then this is Z. Okay. And then they say you also have triangle M and P. M and P, where M is 50. And 70 is N. Okay, which leaves us with P, unknown. Okay, then are any of the angles congruent? Now they're asking the question. The solution, just by looking at the corresponding angles, angle X and LM, Y and LN, cannot determine if the angle are congruent. We need more information about the sides or other angles to confirm congruency. So basically what they're saying in a sense is that first calculate these, then you can confirm congruency. Now, knowing that the total number of angles in a triangle is equals to 118, we know that we can continue to say, therefore, 180 degrees is equals to 70 plus 50 plus angle Z in this instance. And then if you solve for angle Z, it's going to be equals to 70 and 50 will give us 120. And then if you take it on the other side, it's going to be 180 degrees minus 120. Then your angle Z will therefore be equals to 180 minus 120, you are left with 16. Okay, so that will be our angle 16. Okay. And then similarly, when we have 50 here and we have 70 and 50 here, it goes without saying that angle P will also be similar in terms of the answer and give us P being equals to 16. And now that you have all the angles, then we can therefore say triangle X, Y, Z is congruent to triangle MNP. MNP. Okay, now that you have all the angles been calculated, and then let's go to question number 7. It says classifying polygons. A polygon has 7 sides. What is it called? Now we've learned that there's different kinds of polygons. They got names. And we also learned that every time you see 7 sides, we are talking about a heptagon. Okay. And when we move on to question number 8, it's about angles. This question says a supplementary angle, angle A and B are supplementary. We know what that means. And then they say if angle A measures 120, what is the measure of angle B? Okay, now let's demonstrate that with angles. And then they say it's 120 degrees, and that is your angle A. Okay, and then they're asking for you to get angle B. Now we know that every time you see supplementary, it says angles that are supplementary are always equals to 180. Okay, so if you equate that, it's going to be A plus B is equals to 180, where because you're looking for B, you take A to the other side, which is 180, and we know that A is 120. Therefore, our B is equals to 60 degrees. That's angle B, and that's how you calculate angle B. So it's going to be 60 degrees. Okay, so this is how you go about using the terminals that you have all the time to determine what the question is looking for and how can you put values and what the sum total will mean in terms of how you approach these particular questions. It's very important. Hence, we have given you the terminology video before this one so that you first understand how to define them and what they represent numerically so that you're able to interpret them when it comes to now calculations. So let's meet on the next lesson.